Go Pack Go. What's up, guys? Mr. Hanson 404. It's about that time of the year. Final exams are starting up. So Go Pack Go. What's up, guys? Mr. Hanson 404, and we are about to go over our final exam review for semester 1 for algebra. We cover expressions, common difference, patterns. We cover equations, solving for a variable, figuring out when things are equal or not, inequalities, graphing them on the number line, functions, looking at the graph, finding key points, domain and range, all that good stuff. So let's get started.
All right, guys, so for this part, the equations in front of you are already solved, so you just need to go through and figure out what we did. So for this problem, it's an obvious distributive property situation. There's a number outside parentheses. You multiply by everything on the inside, so that's going to be distributive property, and I'll just write dist prop. The second step, to go from here to here, what changes? Well, I noticed that I went from a -10 and a 4 to a -6, so that tells me that since they're on the same side of the equal sign, I combine like terms, CLT, combine like terms. To go from here to here, the 6 went from this side to that side. 6x is by itself, so that means I added, so APE, addition property of equality, you added 6 on both sides. And to finish it out, we had to divide by 6, so that's the division property of equality, or DPE. And then lastly, we could simplify, we have our solution, you have x equals 7. On the second one, you have 4 minus x divided by 7 plus 6 equals 15. The first thing they did was go from that to a 10, so that tells me that they combine like terms, CLT. Second, we ended up getting the negative x over 7 by itself, so we subtracted 10. And we got, that was subtraction property of equality. And then we must have multiplied to get rid of division, so that's the MP. We multiply by -7, and we end up with our solution. So when you are solving your equations, you should be confident enough to say these things. You should be able to tell people what you're doing when you're solving. All right, so we're going to solve some equations. We have 7x minus 9x equals 42. Combine like terms, we're going to get -2x equals 42. We combined like terms because the terms were like, they were the same. They were both x terms, they were on the same side of the equation. To get the x by itself, we need to divide by -2 on both sides, and we do that and get x equals -21 because it's a positive divided by a negative. So that value for x is the value that makes the left side equal the right side. So if we look at the next equation, I'll train track it to keep myself organized. I notice that I have a number outside of parentheses, and that tells me to distribute by multiplying the number on the outside. So I'm going to get 12x minus 84 equals -72. That's a two-step equation at this point. To solve it, I need to add 84 to both sides. That's going to give me 12x equals 12, positive 12, divide by 12 on both sides, get the x by itself, and x equals 1. For this next one, we don't have any distributive property, but if I look at the left-hand side, I see that I have 2 x's on the left, but I also have that x on the right, so I'm going to have to do something with that. This is going to get me a 10x minus 5 equals 14x minus 21. I combine like terms. Now I'm going to move one of the x's. I personally always move the smaller term to avoid, negatives whenever I can. Negative people mess up the vibe. We get -5 equals 4x minus 21. Two-step equation, add your 21 to both sides using the addition property of equality. You're going to get 16 equals 4x, divide by 4 on both sides, and x equals 4. Okay, so for this next one, we need to write the equation. So Starbucks, I usually get the Java chip frap, but you add white mocha, almond milk, no whip. And a $1 donut. It's really, I haven't really had a good vegan donut in a minute. For $10.50. Look at that. Clearly copy clipped this. Oh, that was my sister. Had a coupon for 50 cents off of the price of each coffee. So I need to write out what I got. So I'm just gonna put it in words. So I got 3 coffees, right? The Java chips. I'm getting a donut, and I'm spending $10.50. Now I also am going to be saving 50 cents off each. So looking at this, I know how much the donut costs, it's $1. I don't know how much the coffees cost, so that's gonna be my variable. So I'm gonna say C equals the cost of one coffee. So it's gonna be something like 3, right? 3C. Still gotta figure out how to get that 50 cents in there. Plus 1 equals $10.50 because I'm spending $10.50. So here's where I gotta think. So if I'm saving 50 cents, off of each, it's gonna be minus 50. But that would be just off of 1. So if I multiply this, this is saying I'm buying 3 coffees at whatever price this is. Their cost minus 50 cents. So this would be the equation that I would use. Now to solve that, distribute, you get 3C minus 150 plus 1 equals 1050. So I distributed the 3, and then I'm going to get 3C minus 50 cents equals 1050. Go this way. It looks like I'm adding 50 cents. Not X. 3C equals 11. Let's divide by 3, and C is going to become 3 2/3. So let's call that $3.67 approximately. Better go to Starbucks on happy hour. Comment down below what your favorite order is from Starbucks. This next problem, we got Wheezy, Drizzy, Jermaine. If you know, you know. And they all got their work shown for how they solve these equations. So you need to go through them each and figure out who did it right and figure out what the person did. So I might solve this on my own first to see the correct answer and then go back and take a look. So let's do that. So here's the equation. First step would be to distribute. So we have 7x minus 6 equals negative 8x plus 44. It's getting a little heated. We're playing polygraph on functions. We got x's on both sides, so let's add 8x. Mr. Hanson's got a question, so I'm gonna help him. Come over here. No, come over here. I'll help you in a second. So I got 15x minus 6 equals 44. Then we need to add 6 on both sides, and we get 15x equals 50. Divide both sides by 15. Nope, by 5. And x equals, by 15. What am I doing? What am I doing? Oh, I'm sorry. By 15. X equals 50 over 15. We can reduce that by dividing by 5. And we're going to get 10 over 3. So if we go up here, we can see that we forgot to flip the sign because it was negative times a negative. If we look over here, we can see that what happened here? Same thing. Didn't multiply, didn't distribute. So
didn't get to finish this yet. We're starting number 5, but I told y'all go Pack Go. We're the NFC Championship. Let's go. See, Lil Wayne was there.
All right, so I'm going to be voicing over this. So the first thing you got to do is label your terms, coefficients, and constants of an expression. That's just not an equal sign. So for our terms, we have 4 of them: the 3z, the negative 8x, the 7y, the negative 90. Coefficients are numbers in front of the variables, and constants are just plain old numbers. So this has a word problem, and you need to figure out what everything represents. So we need to look at each of those terms and the coefficients to figure it out. So I'm going to mark them. So like G goes with how much the Gatorade costs. P goes with the pizzas. Box cookies is just $4.99. So looking at those things, I know that it's going to be $1.25 per Gatorade bottle, $6 per pizza, and just $4.99 for a box of cookies because there's no variable attached to it. So we're just buying one. This expression, C plus 5, where C is the cost of headphones, or you can write it as an equation. C plus 5 is the charger. For S, 4 times the cost of the subs, 2 times the cost of the Doritos, and 8 times the cost of cookies gives you that expression there. For the vocab, you want to know what these are. You want to know what they look like. You want to know how to use them. If you don't, I would definitely put this in your notebook, look them up, ask for help. We've gone over just about all of these, so they'll help you. The 2 first ones you got to know is the mapping is when you show the X and the Y going with each other. A relation is just any relationship between an input and output.
graphs of functions, they have to pass the vertical line test. So you draw a vertical line, it can only touch it one time anywhere on the graph. For this one, you have to check to make sure that the input matches or only goes to one output. As long as each input only goes to one output, you are good to go. So for this first one, none of those x's repeat and they all go to 1y, so this would be a function. I wrote the equation if you're interested. That's a little further what. Letter A and B, same thing. Look at the function representation and indicate if it's a function or not. Letter A is not a function because the input of 10 goes to two different numbers, and the graph of the circle does not pass the vertical line test. Function notation, you need to substitute in your x values and then do the math to get the y values. You plug in domain values. If you're looking for the output for -5, we plug it in. You see that's a negative, which would be positive, and you get 3, so that's the order pair, -5, 3. Do the same thing for 0, just to show you. So the whole point of this is you're plugging in inputs to get outputs, and then you have order pairs. Oh, this one came in weird. But basically the third term would be 15. So 1, 2, 3, third term is 15. This function is continuous, so to find the domain and range, we do like the Chinese finger trap thing. You're writing it as an inequality. From the lowest number to the highest number, domain is on the bottom, left to right axis, and range is your vertical axis, up and down. Domain would be -3 is less than or equal to x is less than or equal to 6, and range is -2 is less than or equal to y, less than or equal to 3, compound inequality. Y-intercept is where the graph of the function crosses the y-axis, and if you see it's marked there, it is 0, 2. So we got a lot going on here. You might want to pause it. But the absolute minimum is the lowest point the graph is. The absolute max is the highest. The relative max is at the top of a hill, but it's not the highest point. So those are all marked. F of 4 would be what's the y value when x is 4. And for this graph, the y value never touches 6. So there is no x value that makes that happen. So on this one, we have a situation. We need to make sure we interpret the independent variable and find the domain and range. So for this car, we have 5 meters per second. Time is seconds, distance is in meters. The domain of 0 to 30 makes sense because that's how far it will go. That one really fast, so I'm gonna forget that. So on this one, we have a function. It's a parabola, the cannon shot. So it's starting at 0, 0. It goes up and then it comes down. You need to find the domain and range using the inequality method, set notation. It would also work if you know how to do that. So the lowest x value is 0. The highest is about 10. The lowest y value is 0, and the highest is about 118. So we continue down, and this is a continuous function because you can measure the height at any time. There's no gaps or breaks. The y-intercept is 0, 0, and the absolute max is in blue. If this goes too fast, just go back and pause it. So for this one, just read the story, make a graph. You have to figure out what the independent was. And this is about speed. So make sure that you guys make a graph about speed. In this graph, we have the age of students and the amount of time they go out to eat. Age would be the independent variable and the amount of times would be the dependent. You need to make a representation of these using table, mapping, and graph, then determine if it's a function or not, and stating the domain and range. So you're going to fill in the table with the x values and y values, and then fill in the mapping. You need to make sure that you draw the arrows showing up the mapping. Make sure you draw in the graph. Ask yourself, is this a function or not? Does it pass the vertical line test on the graph? Does each input map to only one output? And the answer is no, because 14 and 16 map to more than one function. The domain, this is discrete, so you just list out all the domain and range values. For this one, you have to figure out what's going on. So make a function notation, 15h plus 20. H is the number of hours, and this represented multiple ways. Stating the reasonable domain and range, what makes sense. Now, obviously, for this job, you can hire people for as many hours as you'd like, but I just went from 0 to 20 and then showed the associated costs to match that. Similar problem here. The there's 75 sheets on the paper. We're printing, so we have P of T. How many minutes would it take? Well, the rate is going to be the number that is next to the variable. So -5 sheets are printed per minute, and T represents the amount of minutes. So 75 is your starting value, and then to figure out how long it would take to print them, you need to set the total P of T to 0, and T is 15. Show your domain and range. If you did a continuous domain and range here, I wouldn't be upset at it, although that does not qualify for half sheets. Read the situation, figure out your independent, and then we need to make a representation. So we need to make sure we understand the situation. I wrote the function notation 10x plus 5. X is the number of hours. 5 is that commit fee because we want them locked in. Make a table. You can keep that going if you'd like. You could also make a mapping. Make a graph. And we want to know how much is it going to cost for 7 hours of shoveling. By continuing the graph or the table or even plugging in 7 into the function notation, you get $75. This situation is very similar. It's just kind of working backwards. You already have the function notation. So for 4 days of school, what's this going to look like for the amount of money you're spending? Well, you start at $10 and there's $2 in snacks per day. X is the number of days. Y is the money. There's your domain and range. Again, pause this if you need to go back. Inequalities. Solve them just like equations. Graph on the number line. Just remember the special rule that if you multiply or divide by a negative, you flip the sign. So for letter A, you need to subtract 24 on both sides, then divide by -6. That's how you know you got to flip it because you're dividing by a negative. Your answer is all x values less than 2, but not including 2 because that's a less than sign. That's just why you create an open circle. So 1.9999 and every number lower than that is part of your solution set. Those are all the numbers that work. For the next one, you're going to subtract 12 on both sides, divide by -2 on both sides, flip the sign because you're dividing by a negative. All numbers greater than 1 satisfy this inequality and give you a solution. You're going to flip the sign. Remember, flip the sign when you multiply or divide by a negative number. Number line, you always want to give yourself 5 tally marks, 5 numbers. Put your answer in the middle if it's a whole number. If not, put the nearest whole number. Draw an open or closed circle. And it looks like on any of these, we don't have any closed circles because there's no equal to symbol, so they'll all be open. For this one, you solve it, distributing. It's going to be a fractional answer. That's fine. Fraction answers are numbers too. That's x is less than 3.5 if you want to turn it into a decimal. So I do not put 3.5 on my number line. I put 3 and then 4, and it goes right in the middle. So that's how you solve your inequalities. Make sure you always